Assalamualaikum and a very good day to my lecturer, Dr. Shahida and friend. My name is Nofar Habiburaza. Today I will be presenting a topic under chapter 5 which is Optimistic Concurrency Control OCC. This is one of the important concurrency control techniques used in modern database management system, especially in high performance systems. To begin, let me explain what is optimistic concurrency control means. Optimistic concurrency control (OCC) is a technique that allows multiple transactions to run at the same time without using locks. Instead of locking other transactions, the system assumes that conflict will be rare. Because of this optimistic assumption, all transactions are allowed to work freely. However, before a transaction commits, the system will run a validation phase. If the data has changed and a conflict is detected, the transaction is rolled back and retried. OCC help maintain data consistency while supporting high concurrency. Why it is called optimistic? The technique is called optimistic because the system trusts that no one will interfere with the data while a transaction is running. It does not use heavy blocking like locking technique. Instead, OOC lets all transactions continue confidently and only check for conflict at the end. This approach reduces overhead and improves performance, especially when conflicts are uncommon. There are three main phases in optimistic concurrency control (OCC) include read phase. Transaction reads data using a private workspace without logs. Second, validation phase. System check for changes and potential conflict. Third, write phase. If validated changes are applied and saved to the database. These phases ensure that incorrect or outdated data is never committed. Let's take a look for the first phase. In the read phase, no log are used. Each transaction works using its own local copy, so the main database is not touched yet. This allows many users to work at the same time without blocking one another. The goal of this phase is speed and high concurrency. It lets users read and compute as fast as possible before the system performs conflict checking later during validation. Next, in the validation phase, the system begins to compare what the transaction read earlier with the current state of the database. If another transaction has modified the same data, a conflict is detected and the validation will fail. So, if validation succeeds, the transaction proceeds to commit, but if it fails, the system will abort and restart the transaction. This phase ensures that no conflicting or outdated data ever enter the database. Next, we'll take a look for the write phase. In the write phase, if validation is successful, the changes made in the private workspace are committed in the actual database. The version number or timestamp is updated so that future transactions know this data has changed. This phase finalizes the transaction and make the update visible to others. When is optimistic control better than locking? OCC perform better than locking in several conditions. First, in low data contention scenario, when conflict rarely happens, OCC is much faster because it avoids unnecessary locking. Second, read-heavy workload. OCC allows many readers to run in parallel, allow maximum parallelism and high scalability. Third, high availability scenario. OCC avoids long-term locks, so data remain accessible when even if a user pause, delay, or keep a transaction open for a while. And the last one is no deadlock. Because OCC use no lock during execution, deadlock are impossible. This makes OCC a suitable choice for modern applications such as inventory system, ticketing system, online shopping, or any system with many reads and fewer conflicting rights. Now, I will explain in detail how optimistic concurrency control detects conflict using a realistic ticket booking scenario. This example shows how OCC protect data when two or more users try to book tickets at the same time. Step 1. Read phase. Both user A and user B retrieve the same ticket information, which is available ticket is 10 units and the current version is version 1. At this point, both users are working with the same initial data. No law are used and both users proceed freely. For the step 2, user A tried to book 5 tickets, so the system check are there enough tickets? Yes. Has the version changed? No. Still in version 1. So user A booking is successful. The system update the ticket to available ticket is 5 unit and the current version is version 2. Now the official database has been changed. In the step 3, user B is still working with the old data. When user B tries to book tickets, two possible conflicts may happen. Case 1. User B booked 6 tickets, so the system checked the availability of the ticket, but not enough ticket. The transaction will fail immediately. This is an availability conflict, not a version conflict yet. Case 2. User B books 4 tickets. This time the availability is enough, but during validation, the system compared version. User B has version 1, database is now in version 2, checked by the user A. This is a version mismatch, meaning someone has updated the ticket after user B read it. So OCC detects this as a conflict and throw an optimistic locking failure exception. User B must refresh and try again using the latest version. This table summarizes the differences. User A succeed because they commit first, but user B fail because they are using outdated data, which causes either lack of availability or version mismatch. Why this example is important? This ticket scenario is widely used in industry. It clearly shows how OCC prevent double booking, how OCC ensure only the latest transaction is allowed to commit, how outdated data is rejected, and how version numbers prevent inconsistent update. This clearly demonstrates how OCC maintains database integrity even under concurrent access. And it's very suitable for real-time systems such as ticketing, booking, and also inventory control. Although OCC is powerful, it has limitations. First, high rollback rate in high conflict system. Second, validation can be expensive, example for large transactions. Third, not suitable for long-running operation because it can increase the chance of conflict. Fourth, not yearly conflict detection because problems are only found at the end. Fifth, heavy write workload may perform worse than locking. Therefore, OCC is best used when the probability of conflict is low and when the system is dominated by read operation rather than writes. In conclusion, Optimistic concurrency control is a high-performance, log-free concurrency technique suitable for systems with many simultaneous users. It, it improves speed, reduces blocking, and ensures consistency using validation and versioning. That's all from my presentation. Thank you very much.